Welcome back. We're going to do a couple examples today regarding that worksheet that wants you to determine if the expression is equal to sine, cosine, tangent, or 1. I think it's called like practice simplifying expressions or trig expressions, something like that. Well, one thing that we have to remember whenever we're either verifying trig identities or simplifying expressions is these Pythagorean identities that, if you remember, were up on a Amazon poster that was actually on the whiteboard in the classroom, and so I ordered a new one. So it just came in, so I put it up here in my living room. And the three that we have to remember are sine squared plus cosine squared equals 1. And remember, from that one, you can say cosine squared equals 1 minus sine squared, or sine squared equals 1 minus cosine squared. So really, there's 3 and 1 there. And there's also 3 in each of these other two. But the other two are 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. Those are helpful. They come up a lot right in the middle of a problem. So we're going to start off by remembering the directions for this worksheet that we're going to work on. Want us to take each, let me put that poster back over here, take each of the expressions on the worksheet and work them out, mess around with them, do legal math stuff to them until we get either A, sine of x, B, cosine of x, C, tangent of x, D, 1. So we're not finished with any of those problems until we get the expression to be equal to one of these 4. So I picked 2 to work out with you today. And they're the same 2 that are on the document, the PDF that I put on the Schoology page. It's called like Examples to Simplifying Trig Expressions, I think. And the first one is number 3. Cosecant squared x minus 1 equals over top of cotangent squared x. And I see cosecant squared x minus 1, and I think immediately I try to remember those Pythagorean identities. And I have it again right here. The Pythagorean identity we're going to look at is this bottom one. 1 plus cotangent squared equals cosecant squared. If I subtract that 1, I get cosecant squared minus 1 equals cotangent squared. So, bingo bongo, right away, we can change cosecant squared x minus 1, we can change that right away to just cotangent squared x, because that Pythagorean relationship tells me that. So this equals cotangent squared x divided by cotangent squared x. I mean, this one was really, really easy because anything divided by itself, of course, is just 1. So that was D. So number 3, simplifies to 1, and we just get D. So that's how you do a problem like that. Now this one, this guy, he was a little more involved. You notice there aren't any Pythagorean relationships up there right now because there's nothing squared. And all of the Pythagorean relationships involved the trig functions squared. So we can't use Pythagorean relationships with this one. So I think this one's going to be what I sometimes refer to this one as like brute force, because we have to go in and change everything to sine and cosine and see what happens. We might have to like get a common denominator or something. I don't know. We're gonna see. So let's play around with it. So right off the bat, I'm gonna change the whole thing to sines and cosines. Hopefully that'll work. That'll help us. I might have to write kind of small to get it on one poster. Hope you can still see it. All right, let's see. So this is gonna be sine of x plus sine of x divided by cosine of x, divided by sine of x over cosine of x times 1 over, let's see, cosecant is 1 over sine, I think. 1 over sine of x plus cosine of x over sine of x. All right. Goodness gracious. Okay. Now, what I'm not supposed to do right now, remember, I can't just cross off the cosine of x sine x. No, don't do that. That's bad. And so with that, you can't do that either. That's bad. That's not a factor of the top. Please stop doing that. Remember, that's the mistake. You make that mistake, I throw you out the window, I think. But I'm not going to really do that. All right. So this guy, sine of x plus cosine of x. I need a common denominator in order to add sine of x plus cosine of x. So the common denominator, believe it or not, is just going to be cosine of x. So I'm going to take sine of x times cosine of x over cosine of x plus sine of x over cosine of x. Does that make, hope that makes sense? I'm going to change colors so we don't get mixed up with each step. So I'm going to say this equals, I'm going to see if I can do this. Sine of x times cosine of x plus sine of x over cosine of x. That's my numerator. Hope I don't go over the edge with my black marker and write on the wall. My wife would be very upset with me if I did that. Now, I'm going to take, well, you know what? I'm going to go just going to combine these into one fraction. I think that's a smarter thing to do right now. So I'm going to leave sine of x over cosine of x times 1 plus cosine of x over sine of x. Okay? Glad I changed colors, otherwise they'd all be running together. You wouldn't be able to tell one step from the other. Okay. So this is all sines, cosines. I got common denominators, but I see something going on here. That looks like something I might be able to simplify a little bit. I might be able to divide these sine x's out because I got one in the numerator, one in the denominator, and I'm multiplying. So I'm going to do that. I'm going to go ahead and say divide that out. Now notice I can't divide the cosine out because that's 1 plus cosine. So now over here, I'm going to leave my top, I should say, the way it is. I got sine x cosine x plus sine x over cosine x. That's my numerator. All of that divided by 1 plus cosine x over cosine x. And I can't cross those out. Now we're going to keep, change, flip. Hey, if the video is shaking right now, it's not an earthquake. It's my cat was just pawing on the stand that this thing is sitting on. I apologize for that interruption. All right, now if we keep, change, flip right here, we're going to get this numerator multiplied by this flipped. So what I'm going to do to save space on my whiteboard is I'm just going to do keep, change, and I'm going to flip this. Okay, if I do that, this is gone. And then I notice that I can divide those out. Now I'm starting to scratch my chin a little bit because I got this 1 plus cosine x. And I got sine x cosine x plus sine x. I bet if I factor that sine x out of this numerator, I'll get a 1 plus cosine x. Let's see what happens. Let's factor this sine x out of this numerator. And we're going to have sine x times cosine x plus 1. And then we're dividing by 1 plus cosine x. All right, now we're in business because that 1 plus cosine x and that cosine x plus 1, they're the same thing. I can divide those out. And we're left with just sine of x, which I think was choice A. Does this all make sense? I hope it makes sense. It looks kind of ugly now, so if you're just starting to look at the video right here, you'd be like, oh my goodness, that looks crazy. But we started off by doing what I call brute force, which was put it all into sines and cosines. And we had to simplify the numerator, simplify the denominator. We did a little keep, change, flippage. And when we did that, the cosines divided out. We factored out a sine x out of here. We got that, sine x times cosine x plus 1. We divided out with the 1 plus cosine x. And we got A. So now I hope you can do the rest of the problems on that worksheet. There's only like 9 more, I think, because one of them was crossed off, of the 12 was crossed off. So I think there's 9 more to do. Good luck, and I'm going to post this up on my Schoology. See ya.